Alright, so in this video, it's going to be part 2 of the discriminant, video series. So it's going to leave off where the discriminant part 1 left off. So if you haven't seen that, I would make sure to go look back at that. Also, as always, if this video helps, I'd appreciate it if you could like, subscribe, all that good stuff. So on the topic of discriminant, in the last video, I gave you these, cheat codes for how to choose the correct method when we're trying to solve a quadratic, because that's essentially what the discriminant tells us. All right, now, once again, factoring square roots, completing the square, and quadratic formula, those are our options. I guess graphing's technically an option, but it's just not very practical. So just to review real quick, and then we're going to practice this. When you are factoring, sometimes you can use that. It's completely fine. However, you want to make sure that your roots are rational. Okay, if your roots are rational, it's fine to factor typically. Now, square roots, once again, can be used sometimes, but you want to make sure, or you're looking for no bx term. That's the tip-off of when to use square roots. Okay, now, completing the square can always be used. However, there's cases where it's better than others. And the case we want to look for is when there's no x squared coefficient and we have an even bx term. Okay, and then the quadratic formula can be used whenever. It's almost like a last resort. If none of these are going to look like they will work, we want to use the quadratic formula. So let's look at a couple cases, and we're going to see if we can just choose the correct method. And then I won't bore you to death with actually doing each. I'll just show you how we choose the correct method. So let's say we have negative 2x squared plus 144 equals 0. Now, the first thing we can do is figure out what the discriminant is. Okay, so we can find the discriminant here by saying b squared minus 4ac. Now, I'll be honest with you, here I probably wouldn't even look at the discriminant, but let's just look at it anyway. And I'll tell you why I probably wouldn't waste my time with this, but I'll tell you that in a second. So d is going to be equal to, let's see, b squared, since there's no bx term, which is partly why I'm saying I wouldn't even go this far. But since there's no bx term, we're going to say 0 is b. So 0 squared minus 4 times negative 2 times 144. That's going to give me positive, since there's two negatives here. So these two negatives are going to give me a positive. That's going to give me positive 1,152. Now, what I know from that is I have two irrational roots. So they're two irrational roots. All right, now, once again, that's all covered in the previous video. So now, what I would do is look at this case and say, okay, I know the roots are going to be irrational, which means factoring is out. So factoring's out because I want rational numbers. Now, if I look at square roots, if I look at complete the square, and I look at the quadratic formula, do I have a situation set up for me where I would be tempted or I would be inclined to use one of those over the other? And if you remember, for square roots, we said no bx term. And if you notice, there's no bx term here. So in this case, the method I would choose to solve this would be square roots. All right, and you can try that on your own. Once again, you can rewatch some of the videos that I've done, and it'll show you how to do that. But I won't bore you to death with that. But that is why, in this case, I would use square roots to solve this. Let's look at another example. Let's say we have 3x squared minus 22x plus 7 equals 0. All right, so now, once again, the first thing we're going to do is find the discriminant. Now, on the last example, let me just go back for a second. Once again, I may not have even looked at the discriminant on this one, because as soon as I saw there was no bx term, I would have immediately said, I'm going to use square roots. All right, now, for this next example, the issue with it is I don't immediately see that I can immediately tell there's a bx term. So I would automatically, on this problem, before I even did the discriminant, I would say square roots is out because this minus 22x is here. So now I'm going to find the discriminant. Negative 22 squared minus 4 times a, which is 3, times c, which is 7. And that's going to give me, let's see, that's going to give me 484 minus 84. So d is equal to, the discriminant is equal to 400. And that's actually a perfect square. So if you have a number that's the discriminant that's greater than 0 or positive and it's a perfect square, that means you have two rational roots. Now, remember we said if we're trying to go through our options of factoring, complete the square, and square quadratic formula. Geez, I can't write. There we go. Quadratic formula, there's only one of those that we said we wanted to have rational roots, and it was factoring. So I would most likely factor this. All right, you don't have to, but knowing what we know about the discriminant, that it's two rational roots, factoring is probably going to be the easiest method that we could use here. All right, now let's continue. Let's do two more. So the next one, it says x squared plus 6x minus 15 equals 0. So what would I do first? I would first say, okay, square roots is out because there's a bx term. So immediately that's out. And then I would say, okay, now what's the discriminant? So we would say 6 squared, which is b squared, minus 4 times 1, which is a, times negative 15. And then I would say, okay, 36 minus, let's see, that would actually be plus, it would become plus 60, which is equal to 96. Now, that is not a perfect square, which means I have two irrational roots. Now, that just eliminated factoring, because remember, for factoring, we want to have rational roots. So now our only options are complete the square or quadratic formula. And actually, both of these options are good options in this case. However, there's one that's better than the other, and it's completing the square. And here's why. For completing the square, we want no x squared coefficient. And if you notice, there's no x squared coefficient here. We know it's 1, but let's just say there's not one there. Then the next thing is we want an even bx term. And 6x would give me an even bx term. So I would use completing the square for this problem. All right, now the last part would be, or the last example would be positive x squared minus 9x plus 21 equals 0. All right, so first of all, I would automatically say square roots is out because there's no bx term. Now I'm going to find the discriminant. We would say b squared is negative 9 squared minus 4 times a, which is 1, times c, which is 21. So then the discriminant is, let's see, 81 minus, that would be 84. So the discriminant is negative 3. Now, if the discriminant is ever negative, that automatically means you have two imaginary roots or imaginary answers. So that doesn't really tip us off other than it eliminates factoring. Factoring is out now. So now once again, our options are complete the square and quadratic formula. But we just looked at completing the square. We said we want no x squared term. We have that. But then remember we said we wanted an even bx term. And if you notice, negative 9x is not an even bx term. So that would eliminate completing the square, which means in this case, I would do the quadratic formula. So once again, some people like to do the quadratic formula every single time. That's perfectly fine. If that's how you want to do this, that's fine. But if we're talking about efficiency and doing it the quickest way possible, in this case, the quadratic formula is probably going to be our quickest option. So that's a complete breakdown of how the discriminant tells us what method to use, or I guess, the discriminant and knowing the tricks about the methods, it tells us what methods to use on solving a quadratic equation.